Today we'll see how to do matrix multiplication using a C program. Okay, so this is what we want to do. Our program should actually read two matrices from the user. In this example, our user should be able to enter all elements of matrix A followed by all elements of matrix B. So once the user has entered these two matrices, our program should actually compute the product P or the product of these matrices and display this particular matrix back to the console so that the user can see what is the product of the matrix A and B. Okay, so if you look to the major steps involved, there are 7 steps. The first one is to read the size of matrix A, that is the row size and the column size of matrix A. After that, we read the row and column size of matrix B. After that, in the third step, we make a check. We see if these two matrices can be multiplied. Well, that depends upon the column size of first matrix and the row size of the second matrix. If these two are not equal, we are not in a position to multiply these elements. So if we have an inequality here, we'll stop or we'll discontinue the multiplication process at this particular step. Okay, and in the first step, we actually read the elements of A. In first step, we just read the size of A, and in fourth element, we'll read the elements of A, and in fifth step, we'll read the elements of B, and in the sixth step, we find the product P. Or this here we find the product of A and B, and in the seventh step, we display the matrix back to the user. Okay, so this sixth step is the only step which may not be familiar for you. So reading the size or reading the elements is something which you already know. But anyway, I'll be going through all these steps today because in step number 6 we are using a set of variables which you may not find easy to understand if we don't go through rest of the steps. Okay, so we'll go through each of these steps one by one. So the first step is to read the size of matrix A. That is, say here, if this is the matrix that you want to enter or the user is planning to enter this particular matrix. So let's see what's the size of it. So here we have two rows here. The first row has elements 5, 4, 6 and the second row has elements 3, 7, 4. So the number of rows here is 2. And what about the number of columns? The number of columns is 3. 1, 2 and 3. Okay, so our aim or what we do in the first step is to enter or store the number of rows to a variable called A row size and then store the number of columns to the variable A column size. Okay, so A has been added as a prefix here because these two parameters are corresponding to the size of matrix A. Okay, so what are the statements that we do here? We are initially telling the compiler that these two variables are of type int. So let's here. So here we have int, and then we are telling A row size and A column size. So with these, the compiler understands that these variables are of type int. And then here in the printf statement, we are prompting the user to enter the number of rows in matrix A that is actually scanned and stored to the variable A row size. After that, the number of columns in matrix A is asked. In this case, it's 3. That's actually scanned and stored to the variable A column size. Okay, so the size of matrix A gets stored to the variables A row size and A column size. And in the next step, we in a very similar manner, we ask for the number of rows in matrix B and number of columns in matrix B. And here we are actually storing these to the variables called B row size and B column size. So earlier it was A row size and A column size, but now it is B row size and B column size. Okay, so the size of matrix A and B. So all those 4 variables are read. So in the third statement or in the third step, what we do is that we check the sizes. Okay, so here the matrix A with size A row size and A column size, matrix B has a size of B row size by B column size. And these two matrices can be multiplied only if A column size is equal to B row size. If there is an inequality here, if these two are not equal, we can't multiply these two matrices. Okay, so that's the check that we are doing here. Okay, and so here we can see if A column size not equal to B row size, then what we are doing, we are printing these matrices cannot be multiplied, and then we are quitting. We are moving away from this function. In our case, we have only one function, main function. That means we are actually quitting the program. Okay, so we can see matrix A and B. we check if these two adjacent numbers, A column size and B row size, are checked. If it is not equal, we quit the program. Otherwise, if we are doing actually, if we are going to multiply, what will be the size of the matrix that we are going to have? So here you can see that this yellow ones are common. We'll take the other one, A row size and the B column size. The final matrix product will have the number of rows that the final matrix will have is A row size, that's from the matrix A, and the number of columns that our product matrix will have will be dependent on matrix B, that is B column size. Okay, and one more variable which you will have to remember. Just remember that the size of matrix P will be A row size by B column size, and then I am also introducing you a variable called common size. Okay, so this common size is this A column size or B row size. Just remember there is a variable called common size, and what is the value that it can have? It can have any of these yellow values, that is A column size or B row size, and these two are equal. Fine. So that was the checking. If A column size is not equal to B row size, we are going to quit the program then and there. And if that's not the case, we'll go to fourth step. That is about reading the elements of matrix A. So here we know that the number of rows that we have is A row size and number of columns is B column size. Okay. So first we want to enter the elements of first row. So we have a loop for that. Int row equal to 0, row less than A row size, row plus plus. So we will go through each of these rows, and within each row we also have to go to each of these columns, isn't it? So we have an inner loop where we write in column equal to 0, column less than A column size, column plus plus. So with these two elements we can iterate to each position within a matrix, and then what do? We prompt the user to enter the matrix or enter the element in a particular position. In this case it will be A00, A01, A02, A10, A11 and A12. So 6 prompts will be there, and with those 6 prompts user will be entering 6 numbers, and that actually gets stored to 6 different locations of the array A. In a similar manner, we also read all the 9 elements or whatever the number may be of the second matrix. Here again we have two loops. In the first loop, the only difference from the first from step 4 is that here we had in step 4 we had A row size, but here we'll have B row size because the matrix has a size of number of rows is here is B row size, and the number of columns is B column size. Okay, so for each position within matrix B, we actually prompt the user to enter the matrix, and we actually store that to the corresponding position within the array. Okay, so this is a 6th step. This is a step which you may not be familiar. The rest of the steps would have been familiar for you. So here, what do? We have 3 loops here. We have int row equal to 0, int column equal to 0, and then there is another loop here. So just for you to understand how the whole thing work, we'll go through the multiplication process once more. Fine. Okay, so if we look at this particular multiplication, so here this is a first, second, and this is a product. Okay. If you look matrix A, here we have A row size, A column size, matrix B, and matrix P. Okay, so finding matrix P, what is the first step? Okay, the first step is to know what is the size of this particular matrix. Size of this particular matrix, we have seen this earlier, will be the A row size by B column size. Okay, A row size and B column size will be the size of matrix P. And so if we know this matrix, if we know the size of the matrix, what do we know? We know that there are these 6 positions where we need to fill in the values. Okay, so the first step was to know the size of the matrix. That is something which we already know by now. Okay, and we'll go to the multiplication process one by one. We'll see that here matrix A, these are the values that you saw here, 546374. 546374, and matrix B 656335157 is written here. Okay, so our problem here is that we know that the size of the product matrix is 2 by 3, but we do not know what these values are. Okay, so for finding that, what do? We actually will go to the multiplication process and see if we can identify some patterns from that. If we can identify some patterns in the multiplication process, then we can write program and we can tell the compiler how to actually do this multiple times with any size of matrices. Okay, so here there are 6 values. Okay, yeah. So here you can see for this we need 6 values. Okay, so I have given okay, so here this is the first position that we had to fill. After that we had to know how to find the second position, then the third, fourth, fifth and sixth. Okay, so in each of these slides I have detailed how we are finding the sum, and by carefully observing this we will try to find a pattern so that we can tell the computer how to do it. Okay, so let's take the first one. Okay, so here the product matrix, the answer that we are supposed to get here is 48. So how do we tell the computer how to get 48? Fine. So here the row meant specified here is row 0. Matrix A, go to row 0. And what is the column? Column number is 0. Go to matrix B and find where is column 0. So this is a row and this is the column which we are going to use for this particular multiplication process. So what are we doing? We look what are the red values here. So 5 and 6, the multiply the red ones, multiply the green ones, multiply the blue ones and add them up all. Okay, so here 5 by 6, multiply 5 by 6, and then 4 by 3 is multiplied, and then 6 by 1 has to be multiplied, and then add it up. Okay, so if we go to the next step, so here again, if we look to this particular column, what is the row number here is 0. So we'll be using this row from matrix A, and column is equal to 1. So we'll take column 1 from matrix A and then from matrix B. And then we'll multiply this row with this column. Fine. And then we'll go to the next element, next position. Again, here this is row 0 and this is column 1. Row 0, column 1. Multiply these two and sum it up, and you're going to get the answers. So that is the same for all 6 cases. So for each position, take the row corresponding to the first matrix and take the column from the second matrix and multiply it. Fine. Okay. So that is the first understanding that you have to do. Beat any position, beat any position in the product matrix. If you want to find the number that you have to enter there, first you will have to find the corresponding row in the first matrix and the corresponding column in the matrix for that particular position. Okay, and it is those two which you will have to multiply. Fine. Okay, so that's about the row and the column which we will have to select. That is based on the actual position of the element that we are looking in the product matrix. So well, that is one point that you have to keep in your mind. So the next one, here we are doing different multiplications, isn't it? So here, if you see, there is 5 by 6, 4 by 3 and 6 by 1. How many multiplications are we doing here? How do we tell the compiler the number of multiplications that has to be done there? So that actually is something which we can get from the common size. Common size actually, if you remember, that is the number of columns in matrix A or the number of rows in matrix B. Okay, so that is something which we have stored in the variable called common size. The common size here is 3. So we tell the compiler, okay, there is a variable called common size, and for each product, each element in a product, how many multiplications do you have to actually do to get that particular value? So that is actually something which we can get from the variable common size. Okay, so the number of multiplications that we do here is 3. If you go to the next, again it's 3, 3, 3, 3 and 3. So everywhere we are doing 3 multiplications. So the number of multiplications is something which we get from the variable common size. Now there are other things that we had to note about. So this you can see here, this table here A and this B. So what are these? These are just details of the values that we are multiplying. So here our first multiplication is 5 by 6 plus 4 by 3 plus 6 by 1. So this 5 is actually from here. So the row number is 0 and column number is 0. So of matrix A 0 0 is 5. So A 0 0. So I have just written it in a bit more explicit manner here in this table. So in similar manner for matrix B. So what is this element 6? Element 6 is actually is from the position B0 0. So B0 0 means I have written its row is 0 and column is 0. Okay, so for each of the elements that we are multiplying, I have explicitly written their row numbers and column numbers. So that is what I have done in this table as well as in this table. Here we have matrix A's details and matrix B's details. and these red ones have to be multiplied together, green ones to be multiplied together, and the blue ones have to be multiplied together. So we know that the number of multiplications that has to be done is common size, but now our next task, or we'll try to understand how will we tell the computer what these row and column values should be. Okay, so there are three multiplications, and for each of these three multiplications, what all do we need? Okay, so we need to know what is the value here. Say here, if you take this example, how do you know it's 0? Should it have been 2, 3, 4, 5? It could have been any number, isn't it? So how do we tell the compiler which number to look here? So that's what we are going to try to understand in the coming steps. Fine. Okay, so how do we find, or how do we tell the compiler you have to look to the position A00 here, or A01 here, or A02 here? How do we write these numbers here so that the compiler can do it in an automatic fashion in a later time? Okay, so you have to note the color code here. So a few of them are in purple and a few of them are in yellow. Okay, so first I think the easier one, we'll go through the ones given in yellow color. So the numbers you can see here are 0, 1, 2. Here the ones in yellow are 0, 1, 2. Even in matrix B, the ones in yellow are 0, 1, 2. So well, that is the case for all the 6 steps. Okay, so this is step 1 for 4800. If we go to the next step for finding 67, here again we have 0, 1, 2, 0, 1, 2. And next step again 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, and here again 0, 1, 2, 0, 1, 2, and 0, 1, 2, 0, 1, 2. So in all the 6 steps, the yellow boxes have to be filled up with 0, 1, and 2. Okay, so where do we get that from? We have the common size 3. So we know that the number of multiplications that we have to do is 3. So it's from there that we get the common index as 0, 1, and 2. Okay, so what is the column? If you look clearly here, you can see here, this is the common index here. So the column, you can see the column of A here is 0, and the row here of matrix B is 0. So this is the common index, 0, 0, 1, 1, 2, 2. They're all equal. So if you go to the next slide, again here 0, 0, 1, 1, 2, 2. They're all equal, and it's all always the same, 0, 0, 1, 1, 2, 2. 0, 0, 1, 1, and 2, 2. Again 0, 0, 1, 1, and 2, 2. Again 0, 0, 1, 1, and 2, 2. So that's it. So these yellow ones are dependent upon common size, and we'll be iterating through each of them, but their values are always going to stay the same. Okay, so here the common size was 3, so that's why we have the values 0, 1, 3. In case common size was 5, the repeating yellow variables values would have been, if common size was 5, the values would have been 0, 1, 2, 3, and 4. If it was 2, the common indices would have been 0, 1. Okay, so these yellow numbers, they are going to be constant. If for one particular value it was 0, 1, 2, then for all other values it's going to be 0, 1, 2. So well, that was the easy part here. So the column size and of the matrix AA and the row size of matrix B are going to be dependent upon common size, and the value that it's going to take is common index. So for each of these multiplications, the column size of matrix A and the row size or the row position of matrix B will be the same as the column position of matrix A in each of the multiplications. Fine. So okay, that is one finding again which you have to keep in mind. So now out of these 2, 4, 6, 12 positions which we have to tell the computer, we already know what the 6 values are. Okay, so the yellow ones is something which we already know. So now how do we find the pink positions, 0, 0, how do you find that? Okay, that is even more simpler. So if we take this particular example, here the value here is 48, and the position of row is 0. Okay, so for matrix A, so the matrix A, we'll take this position, we'll give the zeros everywhere, 0, 0, 0. Okay, just recollect the product. The number of rows in the product actually comes from the first matrix. Okay, so matrix A's row has some relationship with the product's rows. Okay, so here the row here is 0, so here the row numbers here are all zeros. And for B actually we know the number of columns that our products is going to have is dependent upon the column size of matrix B. So how do you find these pink values of column? Find what is the position of the element that we are looking in the product. So here it is column 0, so give column 0 everywhere, column as 0, 0, 0. We'll go to the next one. So here again, what are the pink values here? So the position in question has row as 0, so give 0, 0 here, and column is given as 1, so give column 1, 1, 1. Fine. So in a similar manner, you can find all the positions. Okay. So that's it about it. So if we go to the next position again here, which is this position? Position has row is 0 and column is 2. So here give row as we'll give as 0, 0, 0 and column is 2. So we'll give column as 2, 2, 2. Fine. So that is about the multiplication part. So if you go to the next element, in a very similar fashion, you will be able to find it. So here row is 1. So we'll give 1, 1, 1 here. And what is column here? Column is 0. So column is 0, 0, 0. Fine. And in the next case, here row is 1. So we give row is 1, 1, 1. And what is column? Column is 0, 0, 0. So this is a mistake. Okay. So in matrix B at this position, the value of column should have been 1, 1 and 1. Okay. We'll just check it here. So we actually want to multiply 374 with 536. So what is the position of this element 5 in matrix B? That is row 0 and column 1. See, so it should have been column should have been 1 here. 5 comes in column and 3 comes in column 1 and 5 again comes in column 1. So here we have a mistake. This is not 0, 0, 0. We actually should have gone here, looked what is the column number here and written it here. Okay. So if you write this particular column number here 1, 1, 1, 1, then this particular slide will also be right. Okay. So yeah, it's written correctly here. That is the column size here 1, 1 and 1. Okay. This here it's right, but here it's wrong. Fine. And here let's see if this is right. Here the row is given as 1, 1, 1, 1. And what about column? Column is 2 here, 2, 2, 2. Okay, so this slide is again correct. Okay, so we'll now go to our program part. That is for what we have actually gone through the whole process. So here we have given the common size. We have common size is there, and then here what we do, int row equal to 0, row less than a row size, row plus plus, column equal to 0, column less than b column size, column plus plus. So in these two for loops, what are we doing? We are actually iterating. So if this is our product matrix, so we want to reach this position first, then go to this and then this position. Each of these 6 positions have to be iterated one by one. So what do we do? Int row equal to 0, a row less than a row size. Okay, because the product matrix is going to have a size of a row size of a row size. We know that the product will have the number of rows similar to the one in matrix A. So here the number of rows has been given as int row equal to 0, row less than a row size. Okay, and so that is for iterating each of these row one by one. And the next step, what do we want? We want to iterate across each columns. So within each row, we have to iterate across each of these columns. So how do we do that? For that, we are using the variables int column 0, column equal to 0, column less than b column size. Okay, why b column size? Because we know that the number of columns in matrix P is the same as the number of columns in matrix B or the second matrix. Okay, so the product will have the same number of columns as the same number of columns of the second matrix. So that is why the inner loop is been written with column equal to 0, column less than, column size, column plus plus. So with these two loops, we can actually iterate. We will be coming to each of these 6 positions one by one. So now what do we have to do once we reach each of these positions? So P of row column equal to 0. Okay, so in the very first case, we come here and we have to reach ultimately this number called 48. But initially we are writing, okay, let this be 0. Okay, so that is what we have done here. Let us first assume that this value is 0. Okay, so after that, what do we do? after that we have another matrix. So here, if you remember, we have a common index. We have looked to a variable called common size. Okay, so common size determines the number of multiplications that we have to do. Okay, so here if we see p of row column plus equal to, that is p of row column equal to p of row column plus a particular element in A and a particular element in B, those two are multiplied. Okay, so there are some variables here. We'll come to that. So we are multiplying these two elements. How many times? How many times is this multiplication happening? That depends upon the common size. So if common size is 3, we'll have 3 multiplications. So in our example, we are having the common size here is 3. So we'll have 3 multiplications. Okay. And once we have multiplied it, we'll be adding it to the sum here. So initially, this the sum here was 0, but we'll do 3 multiplications. So that is 5 into 6, then 4 into 3, and 6 into 1, and then we will add it up. So with this particular loop, we make sure that we are doing 3 multiplications. So the 3 multiplications are given here, and after each of these multiplications, we are adding the product back to the particular element. Okay. So here we have a particular element here, p row 0. So here initially we are giving this value 0, and to that 0, first we add the product of 5 and 6, that is 5 into 6. So after first step, we will be storing the value 30 here. After that, 4 into 5 will get 20. So 30 plus 20 will be 50. The second step, the first we multiply 5 by 6, and then we are going to multiply 4 by 3. Okay, so 5 by 6 we will get 30, and the next step it will be 4 by 3, which is 12, and the last step is 6 by 1. Fine. Okay, and so the first we have 0 here, and then to that we add 5 into 6, 30. So the first step we add here 30, and then we find the product 12. With 12 we add 30 and we get 42, and with 42 we again add 6 into 1, that is 42 plus 6, which is 48. So we have to do 3 multiplications, and each of these products are added to added consecutively to the value that is stored in this particular position. Okay, so that's it. So here you have to be careful. These two are covered. So here the number of multiplications actually come here, and again you have to see common index equal to 0, and it gets incremented by 1. Okay, so this common index, if you look here, if we have a particular position row p row of column, and what is the element that we had that we selected, we for a row of A is actually dependent upon this value, and the column of B matrix is actually dependent upon this column. Fine. And this value is common. Okay, so the common index, actually we saw those values get started from 0, and that will be incremented till the common size is reached. So that's why we are having the common index here in the center. Okay, for both the column size of matrix A and the row of B, we'll have the variable common index. Okay, so that's it about the multiplication process. So probably you'll have to go through these multiple times or think on it, so that this particular step or this particular multiplication, if these have to get into your mind, if you're not very clear, just go through it a few more times, put some examples and try it. Then it should be easy for you to understand that. Okay, so once we complete that particular process, we just have one step left, that is to actually display the matrix back to the console. So for that we give a printf statement, that is the product of the matrices is, and here you already know for our product the number of rows is dependent upon A row size and number of columns is dependent on B column size. So using those we actually print the matrix back to the user. So now let's see how this works in a program. So this is the code. So the first question is enter the number of rows in matrix A. So I'll get as 2, and the number of columns in matrix A I'll get as 3. Number of rows in matrix B I'll get as 3, and the number of columns in matrix B again 3. So again, so now I had to enter each of these elements one by one. So I'll enter the values which I used in the example earlier. So 5, 4, and 6 in the first row, and in the second row, 3, 7, and 4. Okay, so in the second matrix, 6, 5, and 6, 3, 3, and 5, 1, 5, 7. Okay, so let's see the product here. The product is actually a 2 by 3 matrix, and the values are 48, 67, 92, 43, 56, and 81. So this was the expected result. And the only difference in the code that I'd shown you, I hadn't displayed the matrices A and B. So this I have done just to make sure that my code is right. So matrix, let me just check it. The matrix A is 5, 4, 6, 3, 7, 4, and matrix B is 6, 5, 6, 3, 3, 5, and 1, 5, 7. So that's it. We have got the result that we're looking for. Okay, thank you.